Bismillahirrahmanirrahim. Today I wanted to talk about a topic that we shall revisit again in this course later. And today will be some introduction to these important concepts, and that is transformations. You should probably put an S in there to call it transformations. Transformations are anything that you can do to a figure, anything that you can do to a geometric figure. For example, I can take this segment AB, and it's drawn here in this Cartesian plane, and I can reflect it about the x-axis. In other words, I can put like a mirror image of it over here across the x-axis, so that will fall over here, and this will be like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 over here, and this would reflect over here. Okay, so this is one example of what I could do with this particular figure. I could reflect it. Okay, so this is an example of a reflection. That's not the only thing I could do with this image, and that's what we're going to talk about. Then reflection is actually one example of a transformation. So I'll just say one example of transformation is reflection. Okay, now there are three other things that you can do to any particular figure. The first thing that you can actually do to a figure is called translation. Okay, so translation. Okay, now this is simply taking a figure and moving it about as if it was like a chess piece and going in a different direction on the chessboard. So translation sometimes is also called a just a slide, like you're sliding a chess piece, or glide as you're gliding it along. So these are all synonyms. And so let's do a translation of this segment AB. I'm just going to move it like, right over here, okay, like this, and then see what you're doing is you're moving the whole segment along, and like this. Every single point of the segment is moved like this. Okay, now when you move things or reflect things, okay, there's some terminology that is associated with this. The image that you create, the new image, it would be nice if you just call it the new image, but it sounds like funny because it's just called the image. Okay, so the new image that's produced is called the image. Okay, and the previous image is called the pre-image. Okay, so segment AB is the pre-image, and the resultant new image is just called the image. So we'll just label this the pre-image. Okay, that's just the terminology, the lingo of this over here. Okay, now so here it is, so as not to clutter the graph here. So the new resultant image is called the image, and the original image is called the pre-image. Now also the labeling has certain consensus. So this one is usually called A prime and B prime. So and that's how they're typically read. And then if you do something to this again, you can call whatever the resultant new image A double prime, and then B double prime, like that, and triple prime, etc. So just to distinguish it, that's how these are typically named. They're named with primes. Okay, so that's translation. So as I said, anything that you can do to a figure, and there are four main things that we're going to learn to do over here, and that's called a transformation. And there are four types of transformations. One is a simple translation, which is just sliding or gliding the figure in the plane, kind of like a chess piece moving about in a vertical or horizontal direction, not in curves. Okay, so that's translation. The second is reflection, as I have demonstrated over here, and you can call this one, for example, let's call this one A double prime and B double prime over here. Okay, and the third thing that you can do is over here, let's call it, all right, rotation. So you can rotate a figure in the plane, okay? And then the fourth thing that you can do to a figure that's in a plane is called dilation. So here's dilation. Okay, so today I just wanted to first define these things so you understand what they mean, and then we're going to elaborate on these somewhat today again, but more so again in the future chapters. Okay, so anything that you can do to a figure in a plane is called a transformation, as in transformers. Okay, transformation, and there are four types of transformations. Translation, and translation is just moving it this way or moving this way or a combination thereof. Okay, a reflection is just a reflection about the x-axis or about the y-axis. So you can take a figure like this and reflect it into about the y-axis like this. Okay, and then the rotation and dilation, which I'll talk about briefly. Okay, so now it's important to understand the difference between a rotation and a reflection. So reflection is reasonably easy to understand. I think it's just like a mirror image of that particular image across the x-axis or the y-axis or something else. Now, rotation can be a little bit trickier to understand for people. Okay, so I'm just going to start out with the simple concept over here first, and then we're going to go and I talk about this particular segment. So let's say if I have a segment like this, okay, just laying comfortably on the x-axis like that. Okay, here's a segment, let's call it P and Q. I'm going to rotate this one. Now this one's as x is 1, 0, and 1, 2, 3, 4, 5, and then 5 and 0. Okay, so I'm going to rotate this segment counterclockwise like this. Okay, I'm going to rotate it counterclockwise like this by 90 degrees. Okay, so the resultant image will be something like this. Okay, if I 90 degrees counterclockwise, start over there, and 1, 2, 3, like this. Ta-da! So that's a counterclockwise rotation by 90 degrees, right? Fair enough. So that's a counterclockwise rotation of this particular image by 90 degrees. If I were to rotate it 180 degrees, if I were to rotate this image by 180 degrees like this, so it starts from here, so it's going to go over here, 1, 2, 3, 4 over here, like, and that this would be the resultant image. Okay, so if this was if this is P and Q, the first rotation, the 90 degrees one, would be Q. Sorry, it's yellow, so that would be like Q prime and P prime over here, and this 180 degrees rotation would be P double prime like this, and Q double prime like that. It's fair enough, correct? So that's kind of the concept of rotation. It's not reflecting. It's not like reflecting, right? It's kind of like moving around. And like, if you can imagine, a 45-degree rotation would be like something like this. You know what I'm saying? Okay. So that is that's rotation. Okay. Now, how do you rotate things in this plane over here? I'm going to erase this so we can use this for later. So here's a rule. So the rule for rotation is for every 90 degrees, okay, this is a rule, so let's write that like in red or something. For every 90 degrees, okay, you have to flip the x and y. Okay, so here's an x and y. You have to invert them. So x becomes y and y becomes x, and like this. Okay, so for every 90 degrees, you have to flip x and y, the ordered pair. So you flip every 90 degrees. What does that mean? For example, look, I'm going to rotate this segment 90 degrees this way, okay? And what I mean by that is you're rotating about the origin, okay? That's kind of like you imagine this and flipping it like that, just like we did with this segment. I was rotating about the origin. So we're rotating this segment about the origin, but we're going to rotate it 90 degrees this way, okay, counterclockwise. Now, either way direction you go, 90-degree rotation means you're going to have to change this ordered pair and invert them. Okay, x becomes y and y becomes x. Okay, so I'm going to do a 90 degrees counterclockwise rotation. Okay, so 90 degrees counterclockwise. Now, if I do this 90 degree counterclockwise rotation, the resultant ordered pair is going to be the following. It's going to be 1 and 2, okay, because that's going to be flipped, okay, and then it's going to be 5 and 4. 5 and 4, so they'll both are flipped. But then, see, it started out with the first quadrant, now it's going to end up in the second quadrant, right? So in the second quadrant, however, the x is negative and the y is positive. So the resultant ordered pair would be negative 1 and 2 and negative 5 and 4. Okay, so that's the thing. So you flip it and you give it an appropriate sign. So let's draw this out. If you were to draw this out, negative 1 and up to right here, and negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. I should label this 1, 2, 3, 4 like this. Okay, let me just do a negative 2, negative 4, and then that's 2, and that's 4. So the resultant reflection, the resultant rotation is this one over here. Okay, so this is A prime. Okay, and this is B prime. That's the image, and the pre-image was the red one over here. Okay, so see now this image is 90 degrees rotated over here. Okay, now let me tell you, if we do this over here, as we call it, and this would be like negative 1. I'm going to put it over here, negative 1 and 2. Okay, I'm going to draw in this bigger picture, negative 1 and 2, and okay, and it's going to be negative 5 and 4, like there. So that's the image over here. This is a 90 degree rotation of this AB. That's A triple prime and B triple prime over here, since we have 3 images over here. Now look how this is different if I were to simply do a reflection about this over the y-axis. If I were to reflect this, it would look like this. 1, 2, 3, 4, 1, 2, 3, 4, like this. So this yellow image here is the reflection over here, okay, whereas the blue image is a 90 degrees rotation. Okay, 90 degrees rotation. Okay, and right, 90 degree rotation. Okay, now that's the rotation. All right, so the last one is dilation. But before we do dilation, you said have to make sure that you understand this. Now, what if I were to rotate this one over here, another 90 degrees over here? Okay, another 90, and then I have to flip them again, right? So this ordered pair here would become 2 and 1. This one would become 2 and 1 because you would have to reverse those. Okay, let me write them here, 2 and 1, and then this ordered pair would become 4 and 5. But then you're in the third quadrant, right? X is negative and y is negative. X is negative, y is negative. So the corresponding ordered pair, if you do it, let's say another 90 degrees rotation, would be x is negative 2 and negative 1, which is right here, and negative 4 and 1, 2, 3, 4, negative 5 right here. I hope I see that correctly. So here we go. Okay, so this was a 90 degrees rotation, and this was another 90 degree rotation. Look how different 90 degree rotations are over here. Okay, so this started out as a 90 degrees, and then another 90 degrees rotation. Okay, and if you were curious, here's another 90 degrees rotation taking into the fourth quadrant, and if you again rotate this back to the first quadrant. So this is rotation. The key thing to understand or remember about rotating a image is to understand that for every 90 degrees rotation, you have to flip the x and y ordered pair. Okay, the last one is dilation. Now, to illustrate that, I've used a triangle as an example because you can transform any figure. And this is a dilation. We're going to dilate this triangle. So what we're going to do is we're going to just magnify this. So dilation is stretching or shrinking this. Okay. So now what I have done here is I've dilated this triangle 2 times. Okay, so I multiply every single vertex by 2 and stretch this. This triangle is grown big by twice. So that vertex is that vertex, that vertex is that vertex, and that vertex becomes that vertex. Okay, so that's example of dilation. Now, dilation in mathematics includes both stretching and shrinking. Okay, stretching and shrinking. So they're both called dilations. Okay, most people think dilation is like making it bigger. Making it smaller is also considered dilation in mathematics. Okay, so this was an introduction to transformations. There are 4 types of transformations. The first is translation, or slide or glide. Second is reflection. Reflection about x-axis, y-axis, or some other figure. And third is rotation. It's just tricky for some people to first understand, then becomes easy. And finally, dilation. Okay, so these are the 4 transformations that we really need to know for now, and then inshallah next time we shall elaborate on this. Until then, as-salatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.